In this video, we're going to look at the magnitude of a vector and how to find it. Specifically, how to find the magnitude of a vector from a column vector. Now, we all know that a vector has a magnitude and a direction. And when we represent a vector as a line segment, the magnitude is just the length of that line segment. So let's take that on to looking at column vectors. If we have the column vector A, which is the column vector 3, 4, then we can think about that in terms of the line segment. And that means if it starts down here, it goes 3 across and 4 up, which means it ends up here, and we can draw the line segment between those two. We might call that A and that B. So another way we could write this would be A, B, with an arrow across the top. Now, the magnitude of that line segment is the length of that line. So the magnitude of the vector A is the length of that line segment. So if we consider the right angle triangle here, we have that length is 3, that length is 4. And because this is a right angle triangle, we can use Pythagoras' theorem to find the length of the hypotenuse. And that is the magnitude of our vector. So, a little bit of notation. For the magnitude of a vector, we use two vertical lines, and this is sometimes called the modulus, sometimes the magnitude, and sometimes the absolute value. In terms of vectors, this notation is used for the magnitude of the vector, that is the size of the vector. We could also have written it in terms of A and B. We could have had it written like that. Both of those are the same. And the way we calculate it is we square 3, we add it to 4 squared, and because it's Pythagoras' theorem, we have to square root the answer. So our answer is the square root of 9 plus 16, which is the square root of 25, which is 5. So the magnitude of the vector A is 5. So let's look at another example. This time we're going to consider the vector B, and it is the vector 5 minus 2. Again, we can draw that. It goes 5 across and 2 down. So if we start over here, it goes 5 across and 2 down, so it's going to end up there. So we go down there, so that's our vector B. And again, we can draw in the right angle triangle, 5 and 2. Notice that the minus 2 gave us the direction that we go down, but the distance, the length of that vertical part of the vector, the vertical component, is 2. So now we can do the size of vector B, and it is equal to the square root of 5 squared plus minus 2 squared, which is just the square root of 25 plus 4, which is the square root of 29. And if we were asked to leave our answer in surd form or in exact form, we would finish there. If not, we could turn that into a decimal by writing it as 5.39 to 2 decimal places. And that would be the magnitude of the vector B. So in general, if we have any vector, if we have vector P is equal to x, y, then the magnitude of P is equal to the square root of x squared plus y squared, which is just Pythagoras' theorem in disguise. So that's how we find the magnitude of a vector. We use Pythagoras' theorem, and we can use the values in the column vector within Pythagoras' theorem to find the magnitude.